Good morning, good afternoon, or good evening. Today we will learn about writing chemical formulas for atoms, molecules, and ions. Let's first look through our periodic table of elements. The metals are located at the left side of the metalloids. On the other hand, the non-metals are located at the right side of the metalloids. Metals tend to lose electrons to form cations, while non-metals gain electrons to form anions. When the two combines, both the cation and the anion, this forms what we now call an ionic compound.
Good day everyone. So to start our discussion, let me give you first a short explanation about what is ionic compound. So ionic compound is composed of two different ions which is known as a cation and anion. So these two different ions has their different charges, which cation has a positively charged while anion has a negatively charged. And ionic compound is also composed of two different substances which is known as a metal and non-metal substance.
Before you write the formula of binary ionic compound, we should know first the definition of it. Binary ionic compound contains monatomic ions of different elements. Monatomic means one atom. The cation would be the metal name and the anion would be the non-metal ion name. These are the example of cation and anion. For the cation, sodium, lithium, potassium, calcium, and magnesium. For the anion, oxide, chloride, iodide, fluoride, and nitride.
So here are the example of binary ionic compound. The first example is barium oxide. First, we must write the cation and anion. So here, the cation is barium, the anion is oxide. The formula of barium is Pa2+, while the formula of oxide is O2-. Now, let's do the crisscross method. The charges of two elements will be changed in a crisscross method or through the crisscross method, and it will be the subscript of two elements. So we have the ratio of 2:2. Then next, the net charge of this formula is 0. Why 0? 2 times 2 plus 2 times 2 minus is equals to 0. So where did we get these values? So these two, we get it from the subscript of barium times the charge of the barium plus 2 the subscript of oxide times 2 minus from the charge of the oxide. So the ratio of this formula is 2:2. Our goal is to reduce it from the smallest whole number ratio. So we get the BaO. So this is the chemical formula of barium oxide. Next example is calcium chloride. Calcium chloride. The cation here is calcium. The anion is chloride. So the formula of calcium is Ca2+. The formula of chloride is Cl1-. Then we will do the crisscross method, and we got CaCl2. So this is the correct and the smallest whole number ratio that we get. And this is already the correct chemical formula.
Now, let's talk about binary ionic compounds with metal that have different charges. It contains Roman numerals which indicates the charges of the cation. These are the steps in writing the formula. Number 1. Write the formula of the cation first and the anion second. Number 2. Use crisscross method to balance the charges. Number 3. Reduce the subscripts of cation and anion into smallest whole number ratio if necessary.
Our first example will be the iron 2 oxide. We follow our procedure. First step would be to write the formula of the cation first and the anion second. These kinds of formulas are very easy to write since the charge of the cation is already given. So we write Fe2 plus NO2 minus. Our next step would be to use the crisscross method to balance the charges. So we write, let's bring down iron, which is Fe, and then cross. Bring down oxygen, which is O, and then we cross. Our last step would be to reduce the subscripts of the cation and anion to the smallest whole number ratio. We see here that our ratio is 2:2. We may still simplify it to 1:1. So we write Fe and O. That would be our final answer. Our next example would be the manganese 4 oxide. We follow the procedure. First is to write the formula. We write Mn 4 plus and oxide O2 minus. Our next step would be to use the crisscross method. So we bring down manganese, cross 2, and then we bring down oxygen, and then we cross. Our final step would be to reduce the subscripts of the cation and anion to the smallest whole number ratio. Since our ratio here is 2:4, we can still be able to simplify it to its smallest form. So we'll write Mn and O2, or simply Mn and O2. This would be our final answer.
So now, let's discuss the ionic compound with polyatomic ions. Let's define first what is polyatomic ion. Polyatomic ion is a covalent molecules that has a ionic charge, as opposed to being a neutral molecules, where poly means many, atomic means atoms, and ion as charged particle. In ionic compounds with polyatomic ions, cations and anions are either or both polyatomic. And these are the common polyatomic ions: ammonium, mercury, hydroxide, cyanide, peroxide, nitrate, acetate, permanganate, carbonate, sulfate, dichromate, and phosphate.
Now, let's enumerate the 3 steps of writing formula in ionic compound with polyatomic ions. The first step is to write the formula of the cation first and the anion second. And the second step is to use the crisscross method to balance the charge. And the last step is to reduce the number of subscript to the smallest whole number ratio if necessary. So let's have some example. We have a sodium hydroxide, so the polyatomic here is the anion. So the first step is to write the formula of the cation and anion.
ion. So the formula of sodium is Na positive and the formula of hydroxide is OH negative. By using the crisscross method, we can have an answer of NaOH. So the next example is calcium carbonate. The polyatomic here is an ion. So first, write the formula of the cation and anion. The formula of calcium is Ca2 positive and the formula of carbonate is CO3 negative. By using the crisscross method, we can have a Ca2CO3 positive. So if the subscript are greater than 2 or 2, the parenthesis is needed. So the third step is to simplify the subscript to the smallest whole number ratio. So here the ratio is 2:2. So we can have the ratio into 1:1. So we can have an answer of CaCO3.
A binary covalent compound is composed of two different elements, usually nonmetals. For example, a molecule of chlorine trifluoride or ClF3 contains one atom of chlorine and 3 atoms of fluorine. It also uses prefixes to determine the number of atoms. Mono indicates 1 atom, di indicates 2 atoms, tri is 3 atoms, tetra is 4, penta is 5, hexa is 6 atoms, hepta is 7 atoms, octa is 8 atoms, nona is 9 atoms, while deca is 10 atoms.
The step for writing the formulas for the binary covalent compound was simply just write the formula of the first element followed by the second element based on the prefix used. For this example, we have nitrogen monoxide where we have the formula of NO. Mono indicates that there is only one atom. Another example is dinitrogen monoxide. For this one, we have 2 atoms for nitrogen and 1 atom for oxygen. So we will have N2O.
And that is how you write your chemical formulas. We hope you enjoyed learning this lesson and thank you for watching.